Hey, 7th grade. In this next video, we're going to discuss how to graph equations of lines. And so if you remember in the last unit, we did a lot of graphing using tables. Okay, so I'd give you an equation and you'd make a table of values, and sometimes you picked 5 x values to plug into the equation. Other times I'd give you 5 x values to plug into the equation. You'd do some order of operations, and then you'd get their corresponding y values. And then you would plot each of those points on the coordinate plane and connect the dots. Okay, well, we're going to be graphing today. We're going to be graphing lines, but we're not going to make a table of values for these. We're actually going to learn a different way, and once you practice it enough, it's going to be a little bit faster way to graph equations of lines. Okay, so again, this unit here, we're focusing only on linear functions, so all of the graphs that we do in this unit are going to be lines. There won't be any parabolas, no v's, no square root functions. Everything's going to be a linear function, so everything you do is going to be a line. Before we get into the examples, I want you to realize one thing about lines is that they have 4 different types of slope possible. Okay, every single line is going to have one of 4 types of slope. And so the 4 types of slope we have are as follows. We have positive slope. Positive slope is going to be what we referred to in the last unit as an increasing line. Okay, the line is going to be rising from left to right. It's going to look like it's going uphill. So a positive slope line will look something like this, okay, a line that is increasing. We have negative slope lines. Negative slope lines are going to be those that are decreasing or going downhill. The y values are going to be falling as you go from left to right. So decreasing slope lines will look like this. We have zero slope lines, and we talked about in the first video that a line with zero slope is going to be one that's a horizontal line. So those will look like this. And then we also have lines that have undefined or no slope. And those are going to be lines that are not functions, and those would be vertical lines. Okay, again, these are lines that don't pass the vertical line test, so these aren't functions actually, but we'll still be talking about them in this unit. So those are the 4 different kinds of slope that are possible: positive, negative, zero, or undefined. And it's really important that when you're doing your graphs that you always double check that the slope of the line matches the way it looks on the graph. Okay, so now we're going to be jumping into some examples here. And we're going to be using what we know about slope-intercept form to graph each of these equations. Okay, so as you might recall from the last video that we did, slope-intercept form looks like this. Y equals mx plus b. Okay, your m value again is your slope. That's the coefficient on the x, and then your b value is the y-intercept. That's where the line crosses the y-axis. We're going to be using both of these facts here to help us graph these lines. So if you look at number 1 here, I have the equation y equals 2x minus 1. I know that my m value, or my slope, is 2, and I'm going to write this to help me do my graph as 2 over 1, since it's a whole number. Okay, my b value for this one is negative 1, so I know that this line is going to go through the point 0, negative 1, because that's my y-intercept. So whenever you're doing a graph, you're always going to start by plotting your y-intercept. Okay, so we have 0, negative 1, and I'm going to start my graph right there. I know that my graph is going to be going through this point 0, negative 1. From there, I know that my rise over my run is the ratio 2 over 1. Okay, because my slope is positive 2, we can say that the rise is positive 2 and the run is positive 1. Okay, your slope is going to be in that ratio. So if I keep my pencil on this point 0, negative 1, that means if I go up 2 spaces for my rise and then to the right 1 space for my run, there's going to be another point on this line that would be at the point 1, 1. I'm going to do the same thing, go up 2 spaces for my rise and right 1 space many, many times until I get a lot of points on this graph that form a line. So this is kind of the opposite of what we were doing in the first video, where I gave you a line and you were calculating the rise over the run between the points. Now I'm giving you the rise and the run, and you're actually drawing the points in. So each of these points, if you move up 2 and right 1, or even down 2 and left 1, you're going to have a rate of change of +2 over +1 between each of those points. Okay, I can also do what I just mentioned. If I go to my green point again, my y-intercept, I can go down 2, which is a negative direction, and left 1, which is another negative direction, and I also get a slope of 2. Okay, so I've got a lot of points now, and now I can use a straight edge to connect my dots, and this is going to give me the graph of that equation, y equals 2x minus 1. Okay, so this is a line that, first of all, goes through the y-intercept 0, -1, and that has a slope of +2. That's one last thing that you want to check when you're doing these graphs. You know that your slope here is positive. Okay, so this line should be increasing, and it is. Okay, let's look at number 2 and do the same thing. We have y equals 3/2 x minus 2. So I know that my y-intercept for this one is going to be the point 0, -2. So I'll go ahead and I'll start right there, and I'll plot my point 0, -2. So I know my line is going to be going through that point. Okay, my slope, or my m value for this line, is going to be the fraction 3 over 2. So that tells me that my rise for this line is +3, and my run for this line is +2. So if I go and put my pencil back on this point 0, -2, that means I can move up 3 and write 2 points, and write 2 spaces, and I'll be at this point 2, 1. And then I can go up 3 and write 2 again, and I'll be at the point 4, 4. And I can continue that pattern until I run out of room. Up 3 and right 2 each time. I can also go back to my y-intercept, go down 3 and left 2. Okay, so now I've created a line, once I connect those dots, that goes through the y-intercept of 0, -2, and that has a positive slope of 3 over 2. So again, you want to check and make sure, since we have a positive slope here, that the line is increasing, and it is. Okay, looking at number 3, now we have y equals -1/3 x plus 2. So my b value for this one is +2. That means that my y-intercept, which is where I'm going to start, is the point 0, 2. So I'm going to be above my origin for this line. It's going to be going through this point right here, 0, 2. My slope for this line is -1/3. Okay, so I want you to remember that a negative fraction, you can treat that as one of 2 different ways. You can treat it as -1 over +3, or +1 over -3. Okay, and it's important that you realize that, because that means that you're either going to have a rise of -1 and a run of +3, or a rise of +1 and a run of -3, but you're not going to have both of them be negative. Okay, so watch what happens when I treat it the first way. If I treat it as a -1 over +3, then starting at this point right here, 0, 2, I need to move down 1, which is my negative direction, and right 3, which is my positive direction. And so I'm going to keep doing that pattern over and over again. Down 1 and right 3 until I run out of room. If I go back to my y-intercept and I treat it the other way, +1 over -3, I'm going to go up 1 and left 3. But either way I go, I'm still going to be forming the same line. Okay, whether I go down 1 first and right 3, or up 1 and left 3, I'm still going to be creating a line that is decreasing. Okay, one that has negative slope. So now I'm going to be connecting each of these points, and that gives you the line whose y-intercept is +2 that has a slope of -1/3. Okay, again, your slope is negative, so you want to be sure that the line is going downhill or decreasing, which it is. Number 4, we have y equals -3x minus 1. Okay, so for this one, our b value is -1, which means that the y-intercept is 0, -1. Ambulance is coming. So I'm going to start at 0, -1, and then my slope is -3. So I can treat that as -3 over 1, or +3 over -1. Okay, so going back to my y-intercept here, which again was 0, -1, I can either go down 3 first, and then I would go to the right 1, and follow that pattern over and over again. Down 3, right 1. Or I can go back to my y-intercept. I can do it as, treat it as positive 3 over -1, which makes me go up 3 and left 1. Again, either way you do it, you still get a slope, or you still get a line that has negative slope, a line that is decreasing. So connect our dots. And now we get the line for y equals -3x minus 1. We had a negative slope, so we want to be sure our line is in fact decreasing, which it is. One thing I want you to be careful of when you're doing these graphs, okay, in addition to getting the slope going in the right direction, make sure you're getting the rise and the run correct. Okay, so you're always going to start out by going either up or down, and then left and right. It's sort of the opposite of what we do when we plot a point. Okay, when I plot a point on a number line, I always do the x value first, and then the y value, so I always from the origin go left or right, and then up or down to plot my points. But when you're doing slope, you move in the vertical direction first, either up or down from a point, and then you go left or right. Okay, so a line with a slope of -3 over 1, that's a whole number point. That's going to be a lot steeper, as you notice, compared to a line with a proper fraction point, slope of -1/3, like this. So just make sure your lines have the correct steepness based on whether the slope is a whole number or improper fraction versus a proper fraction, like 1/3. Okay, finally we're going to look at horizontal and vertical lines. We looked at this a little bit in the first video of 5.1, and you'll remember, hopefully, from that video and from what we talked about at the very beginning of this video, that a horizontal line has 0 slope and a vertical line has no slope or undefined slope. Okay? The equations for horizontal and vertical lines are also going to look a little bit different than what you're used to seeing for normal slope-intercept form. If you have an equation that looks like this, y equals just a number, okay, that is always going to graph a horizontal line. So anytime you have an equation that's just y equals a number, okay, without an x variable, there's no x variable, you're always going to have a horizontal line. If you have an equation that's x equals a number, so no y variable, that is always going to graph a vertical line. Okay, and so let's see why that works down here in examples 5 and 6. For number 5, the equation is saying that x equals 3. And what that means is that every single point on the line that we graph here is going to have an x-coordinate of 3. Okay, this is saying that x is always equal to 3 no matter what. Okay, so if we think about that, that means that every single x value has to be 3. That means this line is going to be intersecting all the points, okay, that are 3 comma something. So that means it's going to be intersecting the x-axis here, okay, at 3, 0. It's going to be going through the point up here at 3, 3. It's going to be going through the point down here at 3, what is this, 3, -6. Okay, it's going to be going through the point up here at what, 3, about 13. Every single point that has an x value of 3, that line is going to be intersecting. So it's going to be a vertical line. That's the only way to do that. Okay, x equals 3 is going to be a vertical line through the x-coordinate of 3, 0. So if we just draw a vertical line straight down through that first x-coordinate that we made, okay, right here at 3, 0, that's going to give us the graph for this equation. Y equals 3 is going to be just the opposite. That means that all the y values, okay, of this line are going to be 3. All the y coordinates are going to be 3. So this line is going to be going through the the points 0, 3, 5, 3, -4, 3, -10, 3. Okay, every single point you can think of that has a y coordinate of 3, this line is going to be going through, which makes it automatically a horizontal line. Okay, so it's going to be a horizontal line through the y-intercept of 0, 3. So that's something that I want you to remember when you're seeing equations like this. If you see just x equals a number, that means that every single x coordinate has to be that number. So that's automatically going to give you a vertical line. If you see y equals a number, every single y coordinate has to be that number, which gives you a horizontal line. Okay? If you have any questions over this, as always, feel free to jot those down or email me. Be sure to go back through and rewatch anything that didn't click the first time. And until I see you again, have a nice day. You're all wonderful people. Take care.